Welcome back to the deep dive. I want to start today by asking you a question. Have you ever felt like a wizard? And I don't mean in a video game. I mean, you're sitting at your computer, you have an idea for an app, maybe a dashboard, but you don't actually know how to write the code for it. So you open up one of these new AI tools, you type in a sentence like, make me a sales dashboard that tracks revenue by region. You hit enter, and then it's like magic.
It really is a rush. It's that instant gratification loop.
30 seconds later, you have code, you have a working app, you feel like you just bypassed 4 years of a computer science degree, and about the time it takes to brew a coffee, it's intoxicating.
It is. It's the hello world moment on steroids. But I think we need to talk about what happens after the coffee wears off.
The hangover.
The morning after, exactly. Because that feeling of being a wizard, it's often followed by a pretty harsh reality check when you try to take that magical code and actually do something real with it.
And that's exactly what we're digging into today. We're looking at this massive shift in the coding world. Everyone is talking about vibe coding, just, vibing your way to an app. But our research today suggests that if you stop there, you're actually walking right into a trap. We've got a stack of sources articles from Simon Willison, some heavy-hitting reports on engineering excellence from BMK, and some really interesting visual frameworks.
hmm And the central theme connecting all these sources is a pivot. We need to move from vibe coding, which is fast and frankly loose,
Mm-hmm.
to vibe engineering.
Vibe engineering.
Yeah.
Okay, that sounds a lot more serious.
It is. The mission today is to figure out how to keep that speed.
Mm.
Nobody wants to go back to writing boilerplate code by hand, but do it without, breaking the internet.
Yeah.
Or getting fired because you accidentally leaked your company's entire database.
Which is a valid concern. So let's start with the buzzword, vibe coding. I see it all over social media. People are posting videos of them building games in minutes. But what does it actually mean technically?
So the definition we found in the sources is fascinating. Vibe coding is described as managing intent rather than syntax.
Intent rather than syntax. Okay, break that down for me.
Well, think about traditional coding. You had to worry about the syntax. You had to know where the semicolon went. You had to know the specific command to open a file. If you got one character wrong, the computer yelled at you.
Right, the dreaded syntax error. I remember that well.
Exactly. But with AI, you don't really worry about the semicolon. You just worry about the intent. I want a blue button that saves the file. The AI handles the syntax. You are just managing the vibe of what you want.
There's a quote here from Andres Karpathy that I think just perfectly captures this energy. He said, I just see stuff, say stuff, want stuff, and copy paste stuff. I accept all always.
I accept all always. It's a very trusting approach, isn't it?
It sounds incredibly fun. It sounds like freedom. But I get the sense you're about to tell me why that's a complete nightmare.
It is fun, don't get me wrong.
Mm-hmm.
But one of our sources uses a great analogy for this. They compare vibe coding to an impressionist painting.
Okay, like a Monet.
Picture a Monet, the water lilies. From 10 feet away, it's gorgeous. You see the flowers, the reflection on the water, the light. It looks like a complete, perfect image. That's your AI-generated app on day one.
It looks great in the demo.
Right. But now, walk up to the painting, put your nose right against the canvas. What do you see?
It's just blobs,
Yeah.
messy, chaotic strokes of paint.
That is vibe coding. The UI works, the button clicks, the data shows up. But underneath, the code structure, the actual paint, is often a mess. It's unoptimized, it's insecure, and it's fragile. And this leads us to the biggest visual concept from our research today, the day one illusion.
The iceberg.
Yes, the
Yeah.
iceberg. So above the water, you have day one. That's the fun part. Rapid feature generation. Look, boss, it works on my machine.
That's usually where the demo ends, right?
But 90% of software engineering is below the water. That's day two. That's production reality. We're talking about authentication, role-based access control, compliance, error handling, scalability,
Boring stuff.
the stuff that keeps you out of jail. The AI doesn't care about that stuff because you didn't ask for the vibe of an ISO-compliant data architecture. You just asked for a dashboard.
I was looking at the stats in the BMK report and I saw something that actually shocked me. We assume AI makes us faster. That's the whole point, isn't it?
That's the promise.
But they mention a productivity paradox, specifically a 67% debugging penalty. Wait, so does that mean we are actually slower?
In the long run, often yes. The data shows that 67% of developers are spending more time debugging AI-generated code than they would have spent just writing it themselves. And 68% are spending more time on security resolution.
That seems so counterintuitive. If the AI writes the code in seconds, how am I losing time?
Because reading code is harder than writing code, especially code you didn't write. You save an hour generating the script, but then you spend 3 hours figuring out why it crashes when two people try to log in at the same time. It's technical debt, but you're taking it out at a predatory interest rate.
We have a horror story in the notes that illustrates this perfectly. The Anatomy of an AI Failure. It's a case study of a space as a service platform.
This one is chilling because it looks so innocent. The developer asked the AI to write a function called getUserData.
Sounds like the most standard thing in the world.
And syntactically, it was perfect. It ran without errors. But when the security team looked at it, under the microscope, they found 3 fatal flaws.
Okay, lay them on me.
First, a massive security gap. No authentication check.
Okay.
The function just grabbed the data for whoever asked. So if I knew the URL, I could just download your profile.
Okay, that's bad.
Second, it used direct string interpolation for the database query.
I'm not a security expert, but that sounds like SQL injection territory.
It is 101 level SQL injection. A hacker could type a command into the user ID field and just dump the entire database. And the third flaw was the error handling.
Let me guess. I accept all, always.
Basically, it had a catch error block, which looks responsible, but inside, it just logged the word error to the console and returned null.
So if something breaks, the user sees nothing, the system keeps running, and the engineer has no idea why data is suddenly missing.
Correct. It's a silent failure. The code vibed correctly. I mean, it looked like error handling, but it was logically hallucinated.
That is terrifying. It's like having a car where the check engine light has been disconnected, but the car still drives until it explodes.
Exactly.
Okay, so we've established that prompt and pray is a trap. We don't want to be the person who leaks the database, but we also don't want to go back to typing every single character. So what's the solution? This is where Simon Willison comes in.
Simon Willison is fantastic on this topic. He's trying to reclaim the term. He says, look, we aren't going to stop using AI. The genie is out of the bottle. But we need to shift from reckless vibe coding to vibe engineering.
And what's the core difference? Is it just a mindset shift?
It's a shift from I hope this works to I can prove this works. Willison defines vibe engineering as using techniques like defensive prompting and system architecture. It's about being a seasoned professional who uses LLMs to accelerate work, but, and this is the key phrase, stays proudly accountable for the result.
There was one point Willison made that I found really surprising. He said that working with AI agents is actually harder than regular coding.
It sounds wrong, doesn't it?
It does. If the robot does the work, shouldn't my job be easier?
It's physically easier. You're typing less. But mentally, it's much harder. Because when you are vibe engineering, you aren't just a coder anymore. You are a site manager. You are the architect.
I love the analogy he uses for the AI itself. He calls them a growing army of weird digital interns.
It is the perfect description. Imagine you have 10 interns. They are incredibly fast. They've read every book in the Library of Congress. They can type at light speed. But they have zero common sense. They are eager to please, and they will absolutely lie to your face if they think it's what you want to hear.
So if I say, build me a bridge, they'll build it out of cardboard if I don't specify steel.
Yes, and they'll paint it gray so it looks like steel. Your job as the vibe engineer is to go around with a hammer and hit everything to see if it's solid. You have to manage the interns, not just let them run wild.
This brings us to the verification paradox. If I have to check every line of code the AI writes, am I really saving any time?
That's the million-dollar question. And the answer requires a new way of testing. Traditional testing checks syntax. Does the code compile? But with AI, the syntax is usually fine. You have to test the outcome.
But wait, I see a trap here. If I'm lazy, can I just ask the AI to write the tests too? Hey, AI, write code for a login and then write a test to make sure the login works.
The hallucination loop. This is where people get burned.
The hallucination loop.
You ask the digital intern to do the work, and then you ask the digital intern to grade its own homework.
And of course, it gives itself an A+.
Every single time. It'll write a test that passes the broken code. It's a closed loop of delusion. The test passes, you get a green check mark, you ship it, and then production breaks.
So how does a vibe engineer fix that?
Contract tests. You, the human, define the boundaries before you generate the code. You say, I expect the output to look exactly like this. I expect these security headers to be present. You write the test, or at least you verify the test logic, before the code exists. You never ever let the AI grade its own security homework.
Okay, so that's the theory. You're the site manager, don't trust the interns. But let's get practical. If I'm sitting down today to build a project, what tools do I actually use? Because the prompt box is just a blank white bar. It's intimidating.
It starts before you even type a prompt.
Hmm.
It starts with the governance of context. You need a rule architecture.
We saw mentions of specific files like .cursor rules or clioee.md. What are those? Are they like settings in the app?
They're actually just text files you put in the root folder of your project.
Yeah.
Think of them as the employee handbook for those digital interns.
So every time I start a new chat, the AI reads that file first.
Exactly. And there is a golden rule here. LLMs prefer multiple small, scoped rules over one big generic one.
So don't just have one file that says be a good coder.
Right. You want specific files. For example, you might have a domain.rules.md. This defines your vocabulary. You tell the AI, in this project, we call it an auditorium, not a room.
That seems like such a small detail. Why does that matter so much?
Because if you don't define the language, the AI will drift. It'll start using generic terms, and suddenly your code doesn't match your business logic anymore. You spend hours refactoring just to get the names right.
Okay, so we have the handbook. Now what about the actual request? The prompt itself, I feel like I just ramble at the AI until it does what I want.
And that's why you get the Monet mess. We have a framework for this called BMAD. BMAD.
BMAD. Okay, walk me through it.
B is for big picture. You have to state the overall goal. We are building a cinema reservation system. M is methodology. This is crucial. What is the tech stack? What are the constraints? We're using React, Supabase, and Tailwind CSS. A is action. This is the specific thing you want right now. Create the booking controller. And D is details. Handle 404 errors. Use OpenAPI specs.
What happens if I skip the B or the M? If I just say create a booking controller?
Then the AI guesses. It hallucinates the context.
Mm-hmm.
It might write a controller for a Python backend when you're using Node.js, or it might invent a database structure that doesn't exist. You have to anchor it in reality.
We also talked about defensive prompting. It sounds aggressive. Are we like fighting the AI?
Sometimes you literally use caps lock.
Really?
Yes, you add constraints like no changes to database schema without asking, or do not remove unused import.
Why would it remove unused import?
Because it's trying to be helpful. It sees an import you aren't using yet and thinks, oh, I'll clean this up. Then 5 minutes later, you try to use that library and it's gone. You have to set guardrails because the AI is overeager.
So we've got our handbook, we've got our BMAD prompts. The code comes back. It's 500 lines of code. I'm not going to read every semicolon that defeats the whole purpose. But you said we have to verify. How do we do that efficiently?
You develop a new skill called impressionistic scanning.
We're back to the art analogies.
It works. It's a 3-step process for reviewing code quickly but effectively. Step 1, Gestalt review. You look at the shape of the change. Does it look right? Is it modifying the files I expected? Or is it weirdly touching the configuration file?
Just a gut check.
Right. Step 2, pattern matching. Does this look like a standard React component? Does the indentation make sense? You're looking for things that just look off. And step 3, the momentum check. This is the most important one. Is the AI hallucinating a new pattern? Did it suddenly decide to use a different styling library halfway through the file just because it saw it in its training data?
It really is like being an art critic. You're looking for a fake. Wait, Monet would never use that shade of neon green.
Exactly. You're looking for inconsistencies in the vibe of the code structure. You don't read every character, but you scan for the smell of bad code.
I want to zoom out a bit. We've talked a lot about the individual developer, but most of us work in teams or for companies. How do you take this weekend build energy and make it enterprise ready?
This is the graduation path. The BMK report describes it as a funnel.
Okay, what's the funnel?
At the top, you have the sandbox. In the sandbox, vibe coding is allowed. Go crazy. The code is disposable. You're just validating that an idea is good. Speed is the only metric that matters.
So no security police in the sandbox?
No. But you cannot deploy the sandbox. If the idea works, you move to stage 2, the audit and handoff. This is where the party stops. Human review, security scans, refactoring.
This is why you pay the tax.
You have to. And finally, production, strict engineering, CI/CD pipelines, observability.
The report mentions that leadership has a huge role here because usually IT departments just want to ban these tools. No AI allowed.
And that never works.
Yeah.
That just creates shadow IT. People just do it on their personal laptops. Instead, leadership needs to build paved roads.
Paved roads. What does that look like?
Create reusable, secure components for the hard stuff.
Mm.
Identity, data access, secrets management. If the company provides a pre-built, secure way to log in users, the developer will use it because it's easier than prompting the AI to write one from scratch.
You make the secure path the easiest path.
Exactly. If you give them a login button component that handles all the security, the digital intern can't mess it up.
There's one last piece of the puzzle here regarding documentation. Usually, documentation is just, here is how the code works. But the sources suggest a project completion report that includes something new.
Right. You need to document the prompting strategy. Which AI tool did you use? What prompts worked? What failed?
Why does that matter? The code is written.
Because if someone else has to maintain it or expand it, they need to know how to talk to the interns that built it. You are documenting how it was built, not just what was built. It prevents the project from becoming a black box that everyone is afraid to touch.
I have to ask the question that I think is on everyone's mind. Listening to this, it sounds like the job is changing completely. If I'm a coder who prides myself on knowing every syntax rule of Java, am I obsolete?
You aren't obsolete, but your value proposition is shifting. Your skills matrix is rotating 90 degrees.
Rotating how?
Old skills,
Yeah.
syntax memory, typing speed,
Hmm.
memorizing the standard library. Those are basically commodities now.
Huh.
The AI has them covered.
So what are the new skills?
Architectural vision, debugging, review, and prompt engineering. The programmer is no longer the bricklayer. They are the architect and the site manager.
You have to know what good code looks like, even if you aren't the one typing it.
Precisely. You need taste.
That brings us to a really interesting final thought from the research: the concept of material disengagement.
It sounds philosophical, but it's very real. As we stop manipulating the text files ourselves, as we stop physically writing the code, we're becoming less of a writer and more of a curator of logic.
A curator. That feels very different.
It is. And the dangerous question is our taste level good enough? Can we tell the difference between a masterpiece and a hallucination?
Because if we can't,
If we lose that ability to discern, if we lose that taste, then we are just flooding the world with functional garbage. We become curators of junk.
that is a heavy thought to leave on. Are you a writer or are you a curator? And is your eye sharp enough for the job?
It's the defining question for the next generation of engineers.
Well, on that note, I'm going to go check my .cursor roles file. Thank you for walking us through this.
Happy engineering.
And to everyone listening, embrace the speed, but respect the structure. We'll see you in the next deep dive.